Hello, and I wanted to talk to you a little bit today about the importance of salt bridges in voltaic cells, or how maybe they're not as important as we all make them out to be. So here we have a solution of zinc sulfate, 0.1 molar, and we have a solution of approximately 0.1 molar copper sulfate. Now, if I take some zinc, take some copper, and have them hooked up to a voltmeter, we can go through and try to record it, and nothing happens. Right now it essentially remains 0. Then we can actually add a salt bridge. So here I have a paper towel soaking in some salt water. We can push this between our two cells, and this will essentially help us to complete the circuit, and we can see that we are getting out 1.03 volts. All right. Now, it should be 1.1 volts, but our concentrations of our zinc and copper sulfate probably aren't exactly even, so we'll change it up just a little bit. But we can go through and we can modify our salt bridge a little bit as well. So I can tear this apart. And now I'm going to balance my electrodes and hold on to the salt bridge pieces with my fingers, and we can see that we get out 1.03 volts roughly. If I let go of one end, it drops back down to 0. If I grab it again, I complete the circuit, and we get out 1.03 volts. So this is a fun little demo that you can do called the human salt bridge. It's a good moment to share with your whole entire students. Now, another thing we can try out is, do we even need something that has a salt bridge? So I'm going to use a piece of copper wire, and we'll see if dropping my electrode messed things up a little bit. All right, so I have the copper wire dipped into each solution a little bit, and we can see out that we're getting 0.98 volts. So probably not quite as efficient, but it's actually pretty darn close, and probably part of that is from me dropping my electrode into the solution. All right, so we can actually use something that isn't necessarily even a salt bridge at all. We just need something to complete the circuit. Now, when we're actually doing this chemistry, if you look at the main reactants, we can see that the main thing we are using is copper 2+ and zinc solid. So do we even need a salt bridge at all? So I'm going to take our copper sulfate solution, and I'm going to dip in both of our electrodes, and we get out that we have 0.95 volts. And we don't even need a salt bridge because now the electrons are traveling across the solution. So yes, you do need a salt bridge in order for it to work, but you kind of don't necessarily need a true salt bridge. The main function of the salt bridge is to complete the circuit so that the electrons can travel through. It's a little bit like if you have a broken light bulb on your Christmas lights. It makes it so the whole strand goes out because there's a break in your circuit. The other function of a salt bridge is to help replace the ions that are essentially being used up. So we have some copper essentially plating onto this zinc electrode. That's why it's turning black. And we'll go and wash that off. And then the other function of a salt bridge is to help kind of direct the electrons. We want to make sure that most of the electrons are traveling through our device and not doing side reactions or doing anything else of that nature. And then the final thing of the salt bridge is we want to make sure that we don't really make any other kind of side reactions go on. So basically it's extending the life of our battery that we're making with our voltaic cell. It'll make it last longer or have a higher output for a longer period of time. So anyway, I hope you enjoyed a little discussion on salt bridges, and I look forward to seeing you in the next video.